Welcome back to the second video in our computer science concept series where I'm going to be talking about the binary life. So in this, we're going to be getting into binary and also what machine language is. So in a simple definition, machine language is an extremely low-level programming language, which consists of numbers. And that machine language is what our CPUs read in order to be able to execute instructions. This process of communication begins when we're using our computers because we send information to the computer through editors, IDEs, and usage of different programs. And when sending this information, when this happens, each piece of data that exists on our computers is altered in order to become a sequence of zeros and ones. These zeros and ones are what is known as binary. Much like us as humans who store different pieces of information or experiences in different sections of our brain, the computer's memory is split up into various really small storage locations. Also, we call these storage locations bytes. Now, one individual byte doesn't have much memory, and it only has the ability to literally store either a really small number or one single letter of the alphabet. Therefore, we can say that the computer must have a lot of bytes in order to complete the things that we need to do, right? Definitely right. We also have what is known as a binary digit. Now, a binary digit, or bit for short, is a term that showcases that each byte we have is divided into 8 small storage sections, or locations. To make it easier, you could picture the bit as a set of switches, those switches being set to either on or off. When you take a piece of information known as data and place it into a byte, that information then determines if that switch remains off or is instead turned on, much like a light needing power. The created pattern from this process will in the end represent some piece of data. So let's take a closer look at this. So here we have a set of 8 switches, most being set to 0 due to the fact that they are off, or negative, and 3 being switched on to a 1, or what we also call a positive. So right about now you might be wondering about those numbers that are underneath the arrows. Let's discuss that now. As you notice, each time the number jumps, it also doubles. These numbers can be used to represent our data by adding them on switches together. In this case, we add together the 1, the 4, and the 32 to give us a value of 37. Therefore, what you're looking at right now is the bit pattern for 37. Let's also briefly discuss what you would do if you needed to store information for a number that was larger than 255, which, as you can see, if you added all these together, is the maximum value that can be stored in a bit. In this case, if this was to happen, you would simply use more than one byte to achieve that. So right about now, you might be wondering, why on earth are you teaching me this? I don't need to use binary digits to program, do I? And the answer to that is no. But I'm simply doing this to give you a wider understanding of what goes on inside of your computer. And knowing this information can aid you in the journey to becoming a better programmer in the future. But before we move on, we're going to take one last look at what is known as ASCII, which is a set of numeric codes that represent things like numbers, punctuation, and even letters. So pronounced ASCII, which stands for American Standard Code for Information Interchange, this table connects directly with binary. And when you press a key on your keyboard, for example, that letter is stored in the memory as a binary number. For example, if you were to hit a lowercase a, the number 97 would then be stored in the memory. And for a lowercase b, 98 would be stored in the memory. So you can see where this is going and how this comes in handy. But that's it for our basic overview of binary. I hope you learned something, and I hope you now understand how important those zeros and ones are when it comes to our computers and our data and what we're doing on those computers.